In Chapter 4, we're now going on to Lesson 5, Multiplication with Polynomials. Now, in this section, we're going to be dealing with a number of objectives in multiplication, preparing us for what we'll be doing in Chapter 5, which will be factoring of the products that we get. Now, I'd like you to write the word background in your notes. And for this, write this simple example A, and then in parentheses the quantity B plus C. So you may recall the distributive principle, multiplying A times B gives you AB, A times positive C and AC. Now we have a common factor in both of these terms, that if we want to later take that common factor out, we get back to what we had originally. And this is what we're going to be doing in Chapter 5, reversing this process. But here is the distributive principle, and then reversing it is called factoring. And they're showing it in some detail. We're going to be doing a lot of these, so you don't need to copy this part down. Now, as we look at this, it's still part of our background, but we are going from a monomial here, multiplying it by something, to a binomial times a binomial. And I'll go to the whiteboard to illustrate the traditional way of doing this horizontally. You take your first term, the x, and multiply it by this, the second binomial. Then you take your second term of the first binomial, which is a plus 3, and multiply it by this. And now you're going to distribute. X times x is x squared. X times 8 is a positive 8x. Then 3 times x is a positive 3x. And 3 times 8 is a positive 24. Now often in the middle terms, they're going to be like terms. So you would get x squared plus 11x plus 24. Now, throughout this, we're going to show you how it relates to what we're going to do in the next chapter, and taking this trinomial now, and then eventually factoring it back to its factors. That's going to be a very useful technique. So this is the traditional way, and we'll go back to our regular screen and see they get the same answer. All right, let's do one more. Now, this is a binomial that we're going to multiply by a trinomial. You don't need to write this one down. But again, they're taking that first term of the binomial and multiplying it by the trinomial. And then that second term of the first binomial, multiplying it by the trinomial. And you get a long string of answers. Now I'm going to suggest, rather than do this type of problem horizontally, we're going to do it vertically, and I'll show you that on the whiteboard. And they show it down below as well. And let's set it up together. I do want you to write this one down. So we have it already. I'm going to take away the parentheses from this one. And I'm going to write this one underneath it. And then erase this one. Now, this is called the vertical method, or the long method of multiplication when you have binomials and trinomials, or another trinomial by a trinomial. And the protocol for this is you take this first item and multiply it by each of these up here. Well, since it's a -1 by these, we're just going to change all the signs. This becomes a +4. This is a negative, and I'm going to put a 1 in there for calculation purposes, but we don't usually write the 1. And then a -1 times this makes this a -x². So all I've done is change the signs because I'm multiplying it by a -1. Now when I multiply the 2x by this, notice the signs. A negative times a positive gives me a -8x. This will give me a positive, and I can put a 1 there too, 2x². And then I get a 2x times this gives me a positive 2x cubed. And the key to all of this is put them in the like term columns. That helps organize. And then this is a +4. This is going to be a -9x. Now here you're going to be left with a +1x². But again, we don't write the 1 in our answers. And then 2x cubed. So I've done this vertically. Hopefully it's a better way than doing it horizontally and then trying to organize your like terms. Let's go to the original here and see what they have. And we see we get the same answer. Double checking our work. Okay, that was all background. Now let's do example 1. And as we look at it, copy it down, I'll go to the whiteboard. And you might say, what is this an example of? Well, it's an example of a monomial that is being multiplied by a trinomial. And basically, we're going to use that distributive technique where we multiply each term in the trinomial by the monomial. Now notice we're multiplying, so we're going to be using some of those exponent rules. So a -6 times 2 is a -12. X times x to the second is x to the third. Remember there is a 1 on that. Now a negative times a positive will give you a negative. 6 times 3 is 18. X to the first times x to the first gives you x to the second. We're multiplying. Now, negative times negative for this last term will give you a positive. 6 times 11 is 66. And then we have our x to the first. We don't write that. All right, checking it out. And we see we have the correct answer. Now for example 2, it's a binomial now multiplied by a binomial. And we'll go through the regular protocol for this. Writing it out, 2x times x minus 5 and a +1 times x minus 5. And we're going to just do the distribution. So this is 2x² minus 10 plus this 1 times this is just going to be x minus 5. Now we have like terms in the middle. I forgot to put the x there. All right, that's better. So this is going to be 2x². Now a -10 and a positive 1x gives me a -9x minus 5. And checking our work here, we see 2x minus 9x minus 5 is what we have. So this one checks out. Again, take good notes, double check your work, be careful of the signs. For example 3, pause, take a moment to write it. We will go to the whiteboard and do it. So this is going to be 3x times 5x plus 4. Now we take our positive 8 and multiply it by the second binomial, 5x plus 4. And doing this multiplication, this is 15x squared plus 12x. This is going to be plus 40x plus 32. Now notice our middle terms are like terms. So 15x squared plus 52x plus 32. And checking it out, we want to display the answer. And let's see what comes up here. Oh, there it is. 15x squared plus 52x plus 32. We did well. Okay. For example 4, we'll go to the whiteboard shortly, but you see they are featuring now this vertical method for multiplication, which is another way of doing it, and that's what we'll illustrate here. So take a moment to copy it down. You want to be sure you check it and you have the right values and the signs are correct. So we'll do this a little bit slowly so you can follow it. So positive 3 times a negative 5 gives us a negative 15. Positive 3 times this gives us a positive 12x. A positive 3 times this gives us a positive 15x squared. And you can just check your work again. You've got the right signs. You've listed them nicely. Now, 2x times a negative 5. This is going to give you a negative 10x that you must put in the like term column. 2 times 4 is 8. This is going to be a positive 8. X times x is x squared. 2x times 5x squared is going to be 10x cubed. And again, check your work as needed. Now you add this up, negative 15. Now this is going to be a positive 2x. This is going to be a positive 23x squared. And this is a 10x cubed. Again, there's lots of steps in this one problem, being careful of all the signs, checking it out, and we get a correct result here. Good job. All right, let's go on. Now, for example 5, again, we're multiplying a trinomial by a trinomial. So again, check that you've written it down properly, and we'll do it together. Again, vertical method, I think, is the way to go. Horizontally becomes quite confusing. So 3 times 3 is 9. 3 times this is a positive 6x. 3 times this is a 3x squared. Now here's where we need to be careful with the signs. Negative 2x times this is a negative 6x. This times this is a negative 4x squared. This times this is a negative 2x cubed. but you're developing your like term columns. Now, x squared times this is going to be a positive 3x squared. This times this is a positive 2x cubed. And this times this is a x to the fourth. And we can put a plus there, and we know that this is going to be a plus. So x to the fourth. Now notice these cancel out, so you don't have to write a 0 anything, just leave it blank. Now here we have a 6x squared minus 4x squared leaves us with a positive 2x squared. These also cancel out, and you're left with a plus 9. So again, having it organized this way is a very useful protocol. Let's check it out. And we get x to the fourth plus 2x squared plus 9. Works out well. Now, another very common method of multiplying binomials is the FOIL. And here they go over it in some detail, but we'll go over it too, and you'll take this as background information. Now, the acronym FOIL, F-O-I-L, refers to a procedure by which we multiply two binomials. The F stands for first, which is this term and this term, the first in each of the binomials. So when you multiply these, you get 6x squared. Now the O stands for the outers, which are the first and the last in the series of binomials. So 2x times a negative 7 is a negative 14x. Now the I stands for the inners of your two binomials. This is going to be a positive 15x. And the L stands for the last. A 5 times a negative 7 is a negative 35. Now notice, we have like terms in the middle that we then combine, and we get 6x squared. A negative 14 and a positive 15 leaves us with a positive 1x. We don't write the 1. And we get our negative 35. And once again, tying this into our next chapter, chapter 5, we'll be taking this trinomial and factoring it into its binomial factors. So doing it this way is pretty straightforward because you have a protocol to follow. Here, when we do chapter 5, there's a little bit of art, judgment, knowledge, understanding, and then checking it by FOIL. All right, let's look at what we have here. So you see, we get the same answer, 6x squared plus x minus 35. Going on to example 6. By FOIL. Now, students have found that if they, let's write it up here, F-O-I-L. If you outline using little brackets like this in a sense, there's your first. This will be 2x squared. Now your outers, and I've done this and continue to do it from time to time, plus 8x, inners, plus 6x, last, plus 24. Now grouping our like terms, 2x squared plus 14x plus 24 does the job. And that's what we've gotten here. In example 7, again, take a moment, write it down. We're going to use the FOIL. So our first 6x squared, our outers a negative 10x, our inners a negative 9x, and our last a positive 15. Grouping our like terms, and developing a protocol. Now you'll have your practice and your certified do. And let's check it out. And I believe that was correct. Let's bring it back here. Yes. Now as we go on to example 8, we've copied it correctly. And going to the whiteboard, a couple of key words I'd like you to add here. Now there are cases where we have what are called special products. Because we're multiplying, we're getting products. Now why do we call this a special product? Because something special happens to this. Now let's look at what we have as a binomial, x plus 7. This other binomial is x minus 7. It's actually the same terms, but one's the sum, one's the difference of the same terms. When you have this, these binomials are referred to as conjugates. I'd like you to write that word down. What are conjugates? Well, it's the same terms, but one's the sum and one's the difference. Now when we do this, and we're going to do it by FOIL, we get our first x squared. Our outers is a negative 7x. Our inners a positive 7x. And our last a negative 49. But notice now what happens to our middle terms. When we multiply conjugates, recognizing these as conjugates, the middle terms cancel out, and we're left with a special kind of product, which we refer to as the difference of squares. This is a perfect square. This is a perfect square, and there's a difference of them. So when we have the difference of perfect squares, we notice they will always factor into their conjugates. Again, a hint for what we'll be doing in chapter 5. Going back. Again, this is a special case where the middle terms are the opposites and then add out become a 0. So we've added some extra items here. Be sure to include this in your notes. Going on to example 9, using the FOIL. First, 3x squared. Outers a negative 2x. Inners a positive 33x. Last, a negative 22. Grouping like terms, 3x squared plus 31x minus 22. Checking out our answer. 3x squared plus 31x minus 22. Hit that one on the head. Let's go on. Now, I went over this earlier in some detail, but just adding a little more background. Here is the formal way of presenting the differences of two squares, which is a product that will factor into its conjugates that we've mentioned. And here is the formal way, I guess, of presenting it, that this will become then a squared minus b squared because the middle terms cancel out. And for number 10, we'll use what the book is showing us, writing these out. For example A, since we have it written here, these are conjugates. So it'll be x squared. We don't have to worry about the inners and outers, minus 16. For example B, since they're conjugates, you square these, multiplying the first, which will give you 9y squared, minus 49. And for C, again, squaring these, this times this is x to the 6th, adding your exponents, minus 36. We get the difference then of perfect squares. These are multiplying conjugates. Let's go on. Now, going along with our special products, this is another example, and this is background, and this would be titled Squares of Binomials. Now, here is a binomial that is being squared. Now, this is going to be a very useful thing in our last unit, but a technique we should be familiar with and recognize. This is a binomial that we're squaring. Another way to write it is just to repeat it, and you can FOIL. But there is a special way of doing this. And the protocol for the special way is we take our first term and square it. That'll give us an x squared. We take these two terms, multiply it together, and it's a plus 3, but then double it. So that'll give us a plus 6x. And then you square this second term in the binomial, which will give you a 9. Now let's use the FOILed for doing it also. So this gives us an x squared. Outers, a plus 3x. Inners, another plus 3x. And there's where we get the idea of doubling that in that special technique. And then the last, plus 9. So we get x squared plus 6x plus 9. So there's the special way of doing it, and then there's the regular way of foiling. Again, square the first term, multiply these two together, double it, and then square the second term of the binomial. Now, these results, when we square a binomial, these trinomials have a special name, and we want you to include that in your notes too. They are called a perfect square trinomial. So if you recognize in Chapter 5, and we're building up toward this, that you have a perfect square trinomial, it will factor into a binomial squared. And that's what they're showing us here. All right, let's go on. Now, to make your notes complete, I'd like you to write these rules down here. And these are what you get when you square a sum of terms and the difference of terms. The only thing different is the middle signs here. So pause, take a moment to write this down. This is the rule for squaring a binomial and results in a perfect square trinomials here. All right, this is our last example, and again, you'll have your practice and certify. Let's go to the whiteboard. And most of these are pretty easy, but the D is a little bit of a challenge, so we'll show that in some detail. So we'll use that special method of multiplying a binomial, squaring a binomial. So we square this first term, 25x squared. We multiply these two terms together, get a 5x, double it. That gives us a positive 10x. And we square this last item, that's just going to be a positive 1. This is a perfect square trinomial. We're going to square this, so that would be y to the 6th. We're going to multiply these together. That gives us 3 y to the 3rd, double it, 6 y to the 3rd. We're going to square the 3. That gives us a 9. We're going to square the 10. That gives us 100. Going to multiply these two together. That gives us a negative 10x. Double it. A negative 20x. Square a negative x. Gives us a positive x squared. Now this one's a little tricky, so I will do this one separately for you and in some detail, going to the whiteboard. So there's, in a sense, our binomial that's squared, although this is, because of the parentheses, one term. But we have to square this. That was our protocol. So when I square this, I get this perfect square trinomial. Square the first term, multiply these two together, get the second term, and then square this to get the third term. Now we then have to multiply these two together and double it. So there's the doubling and then multiplying this together. So when I distribute this, I get a negative 2xy. When I multiply this, I get a negative 6y. And then when I square my last item, a negative y squared is a positive y squared. So when I get to this point, I don't have any more like terms. And if I go back to the whiteboard, I see that that's my answer. And this winds up a rather long lesson, but lots of stuff. And again, we'll be having our unit test. And then going into chapter 5, we will be undoing a lot of this multiplication.